Welcome to Scholarsmate. Dear student, today we are going to learn proof that root 2 is irrational. Okay. So friends, first of all, we have to know that what is a rational number. What is a rational number? What is a rational number? If we don't know about what is rational number, then how can we prove that root 2 is irrational? So, first of all, we want to know what is rational number. So, rational number is a number that can be written in the form of P by Q. Okay, rational number is a number that can be written in the form of P by Q, where P and Q are integers, Q does not equal to 0. Clear? Now we get the definition of rational number. Now we are going to prove that root 2 is irrational. So in order to prove root 2 is irrational, so this method that we want to prove is called as method of contradiction. That means we assume a statement that contradicts our question. Okay, so let assume root 2 is rational. Okay, answer begins here. Let assume root 2 is rational. That means question asking here prove that root 2 is irrational. But in this process we assume that root 2 is rational. So we start the answer with a contradiction statement. Okay, so we assume that root 2 is rational. If root 2 is rational, then root 2 can be written as a P by Q, where P and Q both are integers, both are integers, and Q does not equal to 0. Okay, Q does not equal to 0. Let's say that a PQ are co-prime. P and Q are co-prime. What do you mean by co-prime? Co-prime means there is no other common factor except 1. So 1 is the only common factor between the two, then they are said to be co-prime. Here P and Q have only 1 as a common factor. Okay. So if other common factors are there, then root 2 P by Q does not exist. Then another form will come. Okay. So if root 2 equal to P by Q, this statement is our assumption. This statement is our assumption. As we assume that root 2 is irrational, then this is the condition, this is the condition. Okay. So from this statement we get root 2 Q equal to P. That implies root 2 Q square equal to P square by squaring both sides. Squaring both sides. Okay. That implies 2Q square equal to P square. If 2Q square equal to P square, then I can write P square is even number. Even number means 2 divides P square. The number which can be written in the form of 2 into something, that is a even number. That is an even number. Okay. Or 2 divides that number. Here P square is written as 2 into Q square. Okay. Then if P square is even, then P must be even. Must be even. If P is even, so I can write P equal to 2M, where M is integer. Where M is integer. If P equal to 2M, then P square will be 4M square by squaring both sides. That implies P square was 2Q square. So 2Q square equal to 4M square. That implies Q square equal to 2M square. So I can write Q square is even, and also Q is also even. That means P and Q, P and Q both common factor as 2. P and Q both have common factor as 2. This statement is the contradiction. This statement is a contradiction to our assumption. Okay, as we assumed as root 2 as rational. So P and Q both integers, Q does not equal 0, P and Q are co-prime. But here, as I solve to that, I get that P and Q both common factor as 2. So this statement is contradiction to our assumption. So if root 2 is taken as P by Q, then the form of P by Q does not exist. So root 2 cannot be P by Q. So root 2 is irrational. Root 2 is irrational. By this way, you can solve. So this is the proved. You can solve. Root 3 is irrational, and also root 5 is irrational. So please solve these two questions and comment me whether you understand or not. Okay. Thank you. See you in the next video.